All right, let's look at question 4 now. Question 4, it is, what is this? Um, yeah, we'll see what is question 4 as time goes on. Okay, 4 bottles containing organic compounds are found in the laboratory, and then the chemicals are used in various reactions. Okay, yes, this is organic reactions, by the way. Primary alcohol, secondary alcohol, propene, propanoic acid. Okay, sharp. We don't need to waste time on this. 4.1. 4.1, identify the type of reaction that occurs when each of the following reactants are used. So when they combine whichever with whichever. D. Bottle A and D. Alcohol plus, this is carboxylic acid. Alcohol plus carboxylic acid, the type of reaction that occurs, we know that it is esterification. Okay, someone might say condensation, but I do not opt for you to use that word. Okay, esterification, it is just a simple word that you can use. 4.1.2, bromine water and bottle C. Bottle C is propene, it is an alkene plus bromine water. Bromine water is just Br2, and then we know alkene has double bond. So when we add bromine, you're gonna add bromine here plus bromine here, and then we need to break this bond. Remember, a bond, it is formed of two hands. One bond, it is formed so of two hands. When you break it like this, forming one hand, and one hand, it can now hold whatever that you are substituting there of. So here is going to be addition. We are adding bromine water, so you can say it is addition, or more specifically, uh bromination. Bromination. Or if you do not know the type of halogenation addition, it is halogenation. Halogenation. We are adding halogens thereof. So there are three possible answers that you might give. So addition, I just stick with addition if they did not require for the specific. Okay. 4.1.3, bottle B, alcohol, as well as concentrated sulfuric acid. So I know that alcohol and concentrated sulfuric acid, it's now what? This is the type of elimination reaction. But what kind? So this is elimination reaction. What kind? When I now take when I use sulfuric acid, concentrated sulfuric acid thereof, I'm gonna take out the water molecule from the alcohol. Therefore, this will be kind of dehydration. It's very important that you know your reaction condition, guys. Very important that you know your reaction conditions, and then give the structural formula of the alcohol in bottle B. If the alcohol has a prefix of hex, so it has six what? Six carbons. But now bottle B, it is secondary. So before I go anywhere, I just say, okay, let me just focus to the carbon bonded to the OH. It is, since well it is a secondary, it needs to be bonded to two other carbon atoms for it to be what? To be a secondary. Okay, then you can continue and say it's here, so that it becomes six. Others are here, others are here. As long fella, let me see, 1 2 3 4 5 6. Let's not forget the h. The h, you can throw it however, guys. You can throw it however. You can throw it however, as long as now, uh, or you can take this one to this position. Okay, or you can take this one to this position, or take this one to that position. Okay, as long as the king, the one bonded to the OH. Guys, why am I doing like this? This is wrong. Okay, the one bonded to the OH, the carbon bonded to the OH, should be bonded to only two carbons. Okay, that's the fundamentals behind this. So that's basically that, guys. It's easy. 4.3, they say use structural formulae to represent the chemical equation for the formation of The ester called butyl. Okay, butyl tells me that I have 4 carbons on the alcohol propanoid. Propan, it is three carbons. So while using primary alcohol A in bottle A. So okay, let's use primary alcohol A. And we know that the butyl, it is the alcohol, and then the propanoate, it is the carboxylic acid. So it tells me that my alcohol should have 4 carbons, and it is a single what? It is a single, it is a primary alcohol. Can you see bottle A? So it's gonna be what? An alcohol with 4 carbons, just like this, just like that. I mean, and then plus something. What's that something? Propanoate comes from propanoic acid. Guys, it comes from propanoic acid. So it's just easy. Just easy. Propanoic acid, it has 3 carbons. Again, 3 carbons like this. And then double bond OH. Remember, it has a Q. And then it's going to form, and they are telling us that include the IUPAC names for the reactants. Guys, this is the easy 6 marks. So when I include the name, this is gonna be 1, 2, 3, 4. So this is butan. 1, 2, 3, 4. Yeah, I can say butan 1 all. Okay, butan 1 all or 1 butanol. It's fine. And then here I have propanoic acid, noic acid. Maybe it's fine. And then I know that I take uh H from there. Okay, let me write it like this so that I want to show you something. So I take H from the alcohol, I take OH from the what? From the carboxylic acid. And then this is gonna form me what? This is gonna form me water somewhere thereof as part of my product. And then the other product they have already mentioned out that for me, which is what? Butyl propanoate. But how is it gonna join? The O is gonna join to this carbon that has that we took OH from. Again, if I were to redraw it like this carboxylic acid, so that you understand what I'm trying to explain here. Okay. Hopefully it will make sense. You can draw it this way or the way I drew it is still fine. Okay. And then what's important is that here this is the Q, right? So we still have the Q. So I'm saying from the alcohol, we take the hydrogen, and then from the propanoic acid, we take the OH, such that each is left with only one O. And then when I join these, I can start here to there, and I'm just combining them how? Like this H. I'm just writing everything. And then I have an O here. Can you see? It's going to combine with this C. Like that. And then I'm running out of space. Let me try to squeeze that, guys. Let me draw it like this. It's gonna be H C C C 1, 2, 3, 4, and then this is this O here. This O is gonna combine with this carbon. So it's gonna be combining with that carbon. That carbon has double bond O, and then the rest of these, which is just C C H. So I can complete the others, guys. Sorry for squeezing that. But yeah, I want to believe you get what I'm trying to explain the off. What's important is you getting the concept. Okay, so yeah, guys, these are the products, the off. These are the products, the off plus water. Water, you can do it like this, or you can just say it is H2O. It's fine. You can be fancy, you cannot be fancy. It's not important. Okay, so here it's just easy to marks drawing and naming, also drawing and naming, and then this one drawing, and then this one is like that, right? Let's go to 4.4. 4.4, concentrated sulfuric acid is added to the reaction in 4.3. Okay, concentrated sulfuric acid. What is the function of a catalyst, guys? Especially in this reaction. Remember, this is esterification. The reaction condition for esterification, it is the concentrated sulfuric acid as well as heat. But I know that the concentrated sulfuric acid needs is going to do what? Is going to act as a catalyst. Again, what is the function as that of that? Act as a catalyst. Or you can just tell us it's gonna do what? It's gonna increase the reaction rate. Okay, it's gonna speed up the reaction. So that's the function for our catalyst. And then 4.5 says give the name of the functional group for bottle B. Functional group, the name of the functional group for bottle B. Guys, bottle B, it is alcohol. Functional group for alcohol, we know it is hydroxyl group. Guys, these are just easy marks that one needs to be in a position of obtaining without necessarily finding difficulties. Bottle C is used to produce alcohol. Bottle C. If bottle C is used to prepare alcohol, can you see this is propene? Propene, it is something like this, guys. So if this is propene like that, and I need to prepare, it is used to prepare alcohol, I will need a bond here and a bond here so that it becomes OH and H. Actually, the Markovnikovs say richer gets richer, poorer gets poorer. So which one is more richer with hydrogens between these two? It is the one starting. So H will come here, richer gets richer, and then poorer will just get the rest. So we need to add water. So it's going to be the hydration. Okay. Name the reaction condition required. The reaction condition required, you you need water. You need water. Okay, because you're gonna hydrate. You need water and and what is this? Water and sulfuric acid basically. You can check on my video where I uploaded the reaction condition for each reaction, and then there give the structural formula of the major product. So I'm gonna show you what happens. We have that you can put it here, double bond, or here, whichever. It's still gonna be the same thing. It won't affect anything. Just make sure that the hydrogen bonded there, they are exactly four. Each carbon is bonded to exactly four. It has 1, 2, 3, 4 bonds. And then when I need to add what? Water. This is just water. I just break it up. And then it means this one will break into these two, they're off. And then major product follows Markovnikov's rule. Markovnikov's rule says richer gets richer. Between the two, which one has more hydrogens? It's this one. So it's going to get richer. It's going to get more hydrogen. And then this one is just poor. It will just have OH, guys. Just basically that. Guys, do not do OH like this. No. OH, just separate it. So this is now our answer to 4.6.2. 4.6.3, name the type of addition reaction that occurs. The type of addition reaction. So they are telling you it is addition reaction, but what kind? Remember, I told you it is just hydration. Okay. And then the last question, two two products are formed. Two products are formed during this reaction. Two products are formed during this reaction. The products can be separated through distillation. Okay, which reaction are we talking about, basically? Oh, okay, this one, where bottle C is used to produce alcohol. Okay. Then they say through distillation. Okay, distillation, remember, it is where now we are taking out gases. Okay, distillation process, it is the process of collecting gases by heating up the whatever the thing is. Okay, so they say which property of the compounds allows the separation. So distillation works in such a way. Let's say inside the container we have different compounds. Remember different compounds have different boiling point. So when they heat up this one, the one with the lower boiling point will escape first. Again, will escape first. It will form more vapor fast. Again, so uh, the one with lower boiling point will go out first, and then the others will follow. Will follow. So which property are we gonna use there? By using their by using different boiling points. There are different boiling points. So this is the property that is going to allow us to separate the products or whatever that are formed in that reaction of. So it's basically that, nothing difficult, guys. So yeah, let's look at question 5.